we've already been talking a lot about chemical bonding, but in this chapter we're going to dig in a little bit deeper about what actually makes a chemical bond. So atoms and molecules form chemical bonds to lower their energies. And covalent bonds form as a result of an overlap of atomic orbitals. So if we consider the simplest covalent molecule, H2, it's composed of two hydrogen atoms that initially are separated from one another, and each hydrogen nucleus has one unpaired electron. Right? And in this situation, the hydrogen atoms are somewhat unhappy. Right? Hydrogen doesn't follow the octet rule, but it does follow the duet rule. And so the fact that each one of these hydrogen atoms has an unpaired electron is an energetically unfavorable situation. As we start to bring the hydrogen atoms close together so that they can form a bond, the s orbitals get closer together. And as we bring them together, the energy decreases as the electrons in one atom are able to interact with the nucleus of itself along with the nucleus of the other atom, until we get to sort of the optimal distance, where now you can see the two s orbitals overlapping, forming the bond. And this minimum energy in this curve, where the x-axis represents the distance between the two nuclei, this is what we call the bond length. And if we go shorter than that, now we start to get repulsions from the two nuclei. Where they get too close together, the energy starts going up. So when we pull them apart, that requires energy to give us the separated atoms. And if we get them too close together, the energy also goes up. And so this is sort of the sweet spot. So the s orbitals are overlapping, and we minimize the energy of the system. And the reason hydrogen wants to form H2 is because when it forms H2, that's lower in energy than when we have the high energy up here of the two separated atoms. Now, in order to think about the overlap of atomic orbitals to form bonds, we need to remember what the shapes of these orbitals look like. And we're not going to go above, well, really S and P when we're drawing these, but let's remind ourselves what S, P, and D orbitals look like. So S orbitals are spheres, right? The best I could do is a circle drawing in 2 dimensions, right? But it's like a basketball, right? P orbitals kind of look like a dumbbell. And again, this is 3 dimensions. So you can sort of think about it as having 2 balloons that are connected, where you've tied them off. And that's kind of what a p orbital would look like. And then a d orbital is kind of a double p orbital. Not the best drawing. Hopefully you get the idea. It's sort of a 4-leaf clover, but again, it's 3-dimensional. And so this is what the S, P, and D orbitals look like. Of course, there's the weird DZ squared that looks different, but I think it's probably most important to remember these general shapes. So to get more in-depth on chemical bonding, we really have to turn to quantum mechanics. And we're not going to do any calculations with quantum mechanics, but if you go on and take more chemistry classes, you'll get the chance to do that. With the more advanced theories of chemical bonding, there's sort of 2 different ways that we can look at chemical bonds. There's sort of 2 different starting points. In the end, they sort of converge to give us the same answers, but the starting points are fairly different. We're going to focus on valence bond theory. Oops, that was not mine. We're going to focus on valence bond theory. And we've already kind of discussed the basics of this. This is very much based on Lewis structures via CPR, and we're just going to add on to that by talking about the overlapping of orbitals and also talking about an important concept called hybridization that'll help us explain how the orbitals overlap and give us the shapes that we expect from via CPR theory. The other sort of advanced theory of chemical bonding is a molecular orbital theory, and molecular orbital theory is awesome, and it is what most theoretical chemistry is based on. Unfortunately, we don't really have the time to get into that. So I encourage you, take physical chemistry, where we'll get a chance to talk a lot more about molecular orbital theory. But the next video is going to focus on valence bond theory and how to expand our understanding of chemical bonding.